A very simplified function for problem solving any given problem would be to have two units, two variables. And these two variables are processing power multiplied by time. The problem, of course, is with today's technology on artificial intelligence, basically the processing power, you could also say it is intelligence. Because currently, if we have a given set of processing power and then also time, and this time could be a very large time scale, then you probably wouldn't be able to solve the problem. The computer wouldn't be able to solve the problem. So therefore the question is, what is the one thing that makes the whole thing inherently, you could say, learning? What is the whole thing that is the... There seems to be an external variable we haven't considered, and I cannot really pin it down what it actually is. Obviously it is kind of intelligence, because we have to have a general broader view, because processing power is only a part of intelligence. And if we as humans had more processing power, we probably would be more intelligent. So basically, intelligence is the bigger term, is the umbrella term, and processing power is basically only a subcategory of intelligence. So now the question obviously is, what is intelligence? And if we now replace this easy formula with the function basically for solving any given problem, this can be finding a flat, this also can be finding maybe a passageway to another universe. Maybe it's black holes actually, and we can travel through them somehow. We don't know yet, but I'm stating it as if I also would be working on this problem. I am not. But now, if we replace processing power with intelligence, is intelligence actually the term we are searching for? Is intelligence multiplied by time able to solve any given problem, provided the problem is solvable? And even if the problem isn't solvable, I would argue that just by trying to optimize the solution in a way that approximates a good solution, or maybe the inherent problem often is, if you try to solve something, let's just imagine a solution space is actually two-dimensional. So this means, or let's just imagine one dimension. It's basically a line. So for a given function, we have an outcome of 0 to 10. So basically it's a spectrum. You could also have two opposing values, and in between those values you have different proportions of those values. So now the one-dimensional outcome is basically that you have a certain given point on this x-axis. It could be how, on a scale from 1 to 10, how would I rate this given food at a restaurant? This is basically a unidimensional scale. If you now go into two dimensions, we already have two variables we can test, so we have a lot more points. So what I am trying to say here is, given a problem is solvable, there might be different solutions. There might not always only be one solution. This can be explained in two dimensions actually. If we have two dimensions and we have a given problem and we have 2 points that basically equal in terms of outcome. So let's imagine we have our function is x multiplied by y. If we multiply x and y, and we, for one, have the points 2, 5, so it's 2 and then it's 5. And on the other hand, we have 2 and 5. Both have the equal outcome of 10. So 10 is the output of the function. And we have two solutions to this problem. So the idea now is, of course this is not really the solution for the function, because the function is just x multiplied by y. But if we actually try to search basically for a function where the 10 as outcome is the optimal point. So now the question becomes, if a problem is solvable, meaning there are solutions that are somewhat optimal. And the problem now obviously is that there might be, we just don't know what to optimize for sometimes. And that's, if you have a two-dimensional graph, you don't really know what you want to aim for. Of course, it is very easy if you say we want to have the maximum output of something or the minimum output of something. these are very easy functions. And in terms of like translating this to your personal life, maybe you want to maybe just maximize your income. You want to minimize health risks. You want to maximize your healthy years, for example. These are very easy goals because they optimize for these two different functions, for these two different outcomes of function, which are very easy because they have one single solution, which is the maximum value or the minimum value. But even in a maximum function, the problem sometimes is that you don't really know what's in the rest of the function. So it could be that you discover a local maximum, so basically a point that sits on here. So imagine basically a mountain. And now this could be a possible solution. But what also could be a possible solution is that this is only a local maximum, and the whole. So the problem sometimes is that we cannot display these functions, we cannot calculate these functions till infinity. And it could be that we cannot predict what the function is actually doing, and there might be a different maximum, which would be a more optimal solution. What I'm trying to say is, for any given problem, that just not might be, we just don't really know what to optimize for. So therefore, do we actually need a third variable in our problem-solving function, in our very basic problem-solving function, in order to account for this outcome, that basically to account for trying to find the optimization, basically the optimization of the optimization? Or again, should we imply these two optimization functions in the intelligence? So this is basically most of the thought I had. This thought came to me, and this thought, I guess I have to practice my English a little bit better, came to me because I said something similar in a recent video where I didn't really grasp the whole concept and I failed to explain it in this specificity. And now I think this is a very interesting solution, because currently, if you think about artificial intelligence, it's not a very interesting solution, but a very interesting question. If you think about artificial intelligence, what is it still that divides artificial intelligence from organic intelligence? What is it that makes us still the smartest known thing in the universe, the most intelligent thing in the universe? We basically as humans have a monopoly on intelligence still. And now, what would machines have to emulate in order to have basically our problem-solving ability? And also, given our problem-solving ability, what can we actually solve? And what problems can we not maybe solve? Can we solve interstellar time travel, for example? Or what would you actually call it? Inter-universal time travel? So basically time travel between not time travel, but traveling in between universes. And of course the question has to be asked whether this would be possible, because there are basically factors that determine kind of what the universe is made out of. This goes very into physics, and I also cannot remember it as well. I cannot remember it in a way that I could very simplified explain it right now, but the basic idea is that the physics are probably very different in these different universes that might exist. So now the question is, so for example, 100 years ago, Einstein existed and made his famous relativity theory about 100 years ago. So now the question is, at this time, intelligence could only solve this problem up to a point where he said it is not possible to travel faster than light. But now we kind of have a bigger understanding of this whole thing, because we combined the two dimensions of time and also gravity into this time-gravity dimension, which now may kind of warp our idea of time travel into something that is a little bit more acceptable in terms of how possible it is to actually be able to time travel, and also maybe to travel between universes. And also, the more we understand what we are actually made out of. We can maybe simulate this on our own, maybe without the help of artificial intelligence, maybe with the help of artificial intelligence, or maybe artificial intelligence will take over and we were only basically the precursor to artificial intelligence. We were only the apes, not really the apes, because if something like AGI in a few years or in a few decades or a few centuries will begin to exist, then it probably is a much higher order of magnitude in intelligence compared to us. So the comparison of us compared to apes is actually not very good, because if we compare our intelligence to the ones of apes, if you just take IQs, for example, there are apes that have IQs of 70, 80, 90. So it's basically maybe a 20, a 25%, a 30%, maybe at max a 50% increase compared to the average primate. And so what begs the question is if this comparison even is a good comparison, or if we should compare ourselves much more. So if we, as humans, basically are on the same level, if we compare ourselves to the first AGI, more like single-cell organisms compared to AGI in terms of intelligence. That could be an application of this comparison that would be a lot more, that would make a lot more sense. And I think this idea of problem solving is something that's so universal, because that's basically the thing that is, I mean, you can also argue the basic principle of problem solving is only our version of evolution. Because, of course, we can think, but we can only think due to evolution. So basically it is still evolution. We are still evolution. Because if you think about the universe doesn't care. The universe doesn't care about organisms. It's just all in the universe is just matter. And this matter just exists in a way. And then it organizes itself in some way. And sometimes it seems that some organizations have, compared to other organizations, benefits, and they then maybe organize in a way that is actually DNA, and then they may create something that is over time selected and results in something like us humans. And so therefore the question of intelligence, of us as human intelligence, is maybe not so much something that we inherently have or can call our own, but maybe it's just part of a much bigger process of just nothingness, either on the one side, which would be kind of nihilistic, but it would also mean, so the basic question is, to which extent can we influence what we decide? Basically free will, the free will discussion. And there are studies out there which can show that for certain decisions, you can actually predict what a brain decides up to 7 seconds before the person knows that the brain already decided. And that's, in terms of free will, not really a good argument. Also, I mean, if you want to get into the free will debate, I would recommend getting into, or just reading or listening to Sam Harris' book Free Will, which is actually quite nice, I think. But this whole consciousness thing we are currently on, and also in terms of artificial intelligence, it seems that this is a very anthropocentric, I don't know the exact word, I can actually look it up right now. The word is anthropocentric, which is a word I recently learned. I just heard it before, and this is the first time I have spoken it, so therefore excuse my language. So now the idea is, what if our view of consciousness and intelligence is just based on our view? It's just largely biased by what we are actually able to perceive. And this probably is to a large extent true. So now this begs the question of, is problem solving in general just our version of evolution? And I think this is a very nice question with which I can end this short thinking process.